My apology about the noise in the background, it's the washing machine. Andrew, who's a very good friend of mine, sent me this for Christmas. He knows me very well and knows what I like doing, so to tease me he sent me this. He's obviously been in a hurry and broken the retaining strap that goes across there. Also taken the lug out that was should have been there, broken that off. Broken that one, broken that one, broken that one. Okay, he's in a hurry. And he straps it all together, sent it down to me and said, play with that and enjoy yourself. And I think really what he wants me to do is to find out how they work. And so he can understand why they're failing at home, back on his motorhome. From the part numbers, partially that I can see underneath the strap, they look like it's a Mercedes heater door actuator. And well, let's cut it open and find out what's going on. I'll take the tape off. Well, that's pretty plain inside, isn't it? Little motor, loads of gears, turns that. In a moment I'm going to try and find out how to take the motor out. It's called an actuator, and my understanding of actuators is that they have either 1, 2 or 3 positions, so they just go from one end to the next end and then sort of stop. It may have some form of proportional control in that it can be stopped in any various positions, and that we'll find out as we look into this further. All the bits pop out quite easy. The gear train comes out quite easy. That bit goes in there, I think. That goes over there. And that pops in there. No problems getting that back together. When I took this apart, this was all one assembly. The connector is on the PCB like so. I was horrified to find that there was no solder connections, and I thought, oh, that's terrible. But on reflection, it isn't. The pins are designed to be an interference fit on the through holes, and it's a really tight interference fit, and in many respects very difficult to get out. I don't think there's any problems with the connection there. Similarly, the motor is attached in the same way, and hang on, I've got it upside down onto the board, so a whole lot comes sort of pre-assembled like so, taking them apart. With a stepper motor, you can't expect to put a voltage on it and have it spin round. By energising the coils, you create a magnetic field, and on the rotor there's a permanent magnet, and that magnet will then align itself with the magnetic field of the coil, and it will step to that position. And various combinations of powering the coils and reversing the voltages on the coils will make the rotor step round one bit at a time. It is logically driven by a series of ones and noughts, and that's provided by this little board, or be more precise, the integrated circuit that's on this little board. Now, tracing the connections for the coil, there's 1, 2, 3 and 4, they zoom off to pins 6 and 7 for one coil and 9 and 10 for the next coil. There is something that we can actually do at this point with our multimeter, and let me show you. I'm going on one leg of the one of the coils, and this goes either to pin 9 or pin 10, I'm not sure which one. and the other side I'm going to put on earth. So I've got my negative probe on the earth, and you can see that I'm getting 2.9 odd volts. So let's swap that over. So I have a negative on the coil and a positive on to earth, and I'm getting a diode drop, which indicates that this is sort of cathode to anode direction. Now let's go on the leg of the other coil, and the same coil but the other side of the coil, to earth, and again we get that diode drop again. Just to check, go across that way, nothing. Go across this way, we get the diode drop. We'll try the same trick with the other two connections to the coil. This one here and the earth, get a diode drop, and let's check those again. Let's go on. So positive on the earth, negative on the coil, get a diode drop there, and the same there, get a diode drop to earth. If I reverse them round, show you that there's open there and open there. So this is the arrangement we've got, and inside that chip we've got two diodes that are back to back for each coil. So we've got two diodes for one coil, two diodes from the other coil, and they're both going down to earth inside of the chip. That is to eliminate the part of the back EMF of the coils. In this case the negative transitions, those that go negative to earth, will be taken straight down to earth, and that will protect the chip. Now all that looks quite normal to me, and I've seen this sort of arrangement before, and I doubt if there's any damage to the outputs of this device. I can't really tell you any more about this chip other than that these are the numbers on the device. I can speculate about what this chip does, and I shall do that now. One thing for sure that it has inside this chip is the stepper motor drivers. Now that by itself is not enough. We need to create the series of ones and noughts that drive the stepper motor. Therefore it implies it's got an oscillator and some form of logic to derive the ones and noughts to drive the stepper motor. Well, that's all very well, but there doesn't appear to be any sensors anywhere to decide when the actuator has got to its position. I'm going to assume that it knows it's got to its step position when it generates a stall current, so it bangs up against where it's got to open to, and the motor seizes and you end up getting a stall current. So I expect some form of current sensing inside of this chip, and the logic inside the chip will say, oh, I've got a stall current, I must have reached my limit, therefore I shall stop sending signals to the coil and prepare myself to go in the other direction when I get the next message to do so. Now that's rather implied that we've got some firmware inside of this little chip, and when I start thinking about that, I start thinking of microcontrollers. So what we've got, stepper motor, microcontroller. Microcontrollers need to be programmed, so there's going to be a bit of memory, EEPROM memory in there. The chip has to be programmed. How's it going to be programmed? There's going to have to be pins to sort of program the chip. And along the back here there's a series of redundant pins. Well, I think they're redundant as far as I can see. So might just be an SPI interface for programming the chip. And that is total speculation on my part. I may be well off beam. And we need to talk about how does this chip interface with the instructions that it gets. Now, as it comes out of a vehicle, it is not going to be part of the CAN bus, because this is not the heating control, is not part of the engine management system. It's part of sort of air conditioning, climate control inside of the car. So the typical interfaces that they use nowadays is called a line bus. That's a local interconnect network, and data is transferred over one wire. So there'll be one wire on earth to transfer the data. But we have, let's see if I can bring it into sight. We have 4 wires. I would only expect to see 3, but there's 4. I'll explain that in a moment. So next we're going to look at the inputs to this chip, whatever it is, and see if we can make any sense of those. Well, I'm quickly going to go over the input pins. That's the pins from the connector, and we start with putting one of our probes on earth, and let's see if I can hold that down a bit. Earth, and that's showing 0 volts. So that pin, outside pin there, is earth. It's good news. And we'll check the other pins. The other outside pin is showing me a diode drop. So from that's cathode, anode. So we've got a diode drop across there. So that's protecting against any reverse voltages. Let's check the other pins to earth. Second pin in from earth, or first pin in from the earth is pin 2. It's going to be just an open circuit by the look of it. Third pin is open circuit. And fourth pin is diode drop.
I'm doing another job and then I'm finished.
Okay. As long as you're not going to switch the telly on, it's alright. Now, if we look at the second pin in relationship to the third pin in, we've got a short circuit. Let's see how exact that short circuit is. 1.1 ohms. Doesn't strike me as being good. Check with the outside pins. I think nothing, and I wouldn't expect to see anything like going on the other pin. So we have a short circuit between pins 2 and 3, and this little device here, this little thing here, we're going to put our probe on earth. One side of it is short circuit, so that's earth. Put it in diode mode, probably easier to hear it. Diode mode, that's earth. And the other side of it is open circuit. And I can tell you that that side goes to pin 2. So put pin 2, and that side should be a short circuit, which it is. So that pin 2 goes to that side, that component, and that component, if I remember rightly, goes to pin 3 of the IC. the input pin 3 goes to pin 4, up through that pad, through this pad, through that pad, and then barbed wire to pin 4. There's not much more I can tell you about this device at this stage, but what we're going to do is remove the integrated circuit. And that'll be a challenge for me because I've not unsoldered one of these packages before, and I will have to use hot air, which I don't like using. And then we'll be able to draw out the circuit completely and see if it makes any sense. But my guess is that pin 2 and 3 are short circuit, the chip is blown, and 2 and 3 happen to be part of the line bus. Now, I suspect that one side of that pin 2 I'm expecting to be a signal earth, and the transmission line being on pin 3, the input. That's what I'm expecting, although I may be wrong. What does make sense is that this could be the transmission line for the data coming in there, coming out here, sort of daisy chained off to the next actuator, daisy chained out of that to the next actuator, and then on to the control chip, whatever that may be. And that would make some sort of sense, but I get a feeling that this has been blown. It may be that someone has tried to put 12 volts across here to drive the actuator and been trying out the various pins with 12 volts and blown the chip. Well, this could be a bit of a laugh, as I've never done this sort of thing before with these chips. I've only watched other people on YouTube do it, so I'm going to flood it with a fair bit of flux. I must stress this is my homemade flux, and we'll see what happens. Could be a complete disaster. Anyway, it's a bit of a laugh, isn't it? Oh no, I'm not hot enough yet. The flux is bubbling. Oh, something moved. Oh, blimey, that was easier than I thought. Turn it off. Well, it wasn't much of an area to heat up, and therefore a component came off very quickly. Well, oh well. It's the first time for everything. And I haven't knocked any of the components off. There's seems to be a lot of redundancy, but as I said before, I still think it's a stepper motor driver come microcontroller, and that these pins up here were probably used as a programming for the microcontroller, sort of putting the firmware on the microcontroller, prior to this device being soldered in. What the device is, I haven't got a clue. I don't know what the function of these two capacitors are here in the circuit. As we was discussing, pin 8 goes to pin 20 down to earth via a capacitor. Well, via this capacitor to earth, but more importantly, they go off to pin 4, which I think is the power input. So power is being supplied to pin 20 and pin 8. The data transmission lines are going to be pin 2 and pin 3, and they go to pins 3 and 4 on the IC. So the connector pins are pin 2 and pin 3 go to 3 and 4. There's a capacitor going down to earth on pin 3, which is 200 picofarads. Across pins 3 and 4 we have a short circuit. It's not a total short circuit, and that's worries me a bit, because I would have been happy had it been a complete short circuit as opposed to a partial short circuit. One being 0.1 of 0.2 of an ohm for a short circuit, or 1 to 2 ohms being a sort of a partial short circuit, which may mean that this chip has gone. But in part, it doesn't really surprise me that there is a connection between those two, because line bus data transmission is only along one wire. So if we've got several devices on the line bus, I could imagine them being daisy chained together, such that the signal comes in on this wire from one device, out that way the signal comes in through to this device, back out on pin 2, off to the next one. So you've got a daisy chain, and all the command signals go along backwards and forwards along the transmission line, data transmission line. The short circuit here is niggling me, because I would have thought there would have been other ways of doing this, but if you look at the way the connector is and all the wiring that goes on, you would expect that this may be how they do it. I don't know. Now, where do you go from here? He had 3 of them replaced in the vehicle, and why did they fail? Well, if you get a break in the transmission line, you're not going to get a signal to any of them. And could it be that all these devices are absolutely A-OK, and that the fault lay in the connectors along the, as I say, the transmission line? These are the numbers on the device. I can't find an IC that matches any of those numbers, and I'm at a loss to know what to do next. If I knew what the device was, I could use the specification sheet for it and then work out how to drive everything and check everything that was working, but I can't, so I will never know. And I don't think it's really worth chasing. Is it worth my while putting all this back together again? Well, I don't really think so. He's had the vehicle repaired, and should it happen again, I've told him where to get these things at a reasonable price. I don't think there's any mileage in this, because we don't know what this chip is. If I knew what the chip was, different story, we could take it a bit further, but no, not really worth it. Although I don't like leaving it like this. I feel that it's a job sort of half done, and it's annoying me. Best to get rid of it. Whilst editing a video, I had second thoughts about this little component here. On the board, if we put that there for a moment and zoom in, now this device, although it measures 200 picofarads, it's a different colour to the other capacitors on the board. I find that quite worrying. I gave it some thought, and I think this is more likely to be a transient voltage suppressor. If this is a transient voltage suppressor, I expect it to be a bidirectional one, and pin 2 here, which is pin 3 on the device, pin 2 on the socket, I expect to be a data line, and pin 3 I think may be a wake-up line. I keep on referring to this as a line bus, when in fact I mean a LIN bus, L-I-N, and that's local interconnect network. And I think that pin 3 is a wake-up signal to the chip. So you've got a wake-up line coming in on pin 3, and that'll either be a 0 or a 1, and the line bus will have the data. There I go again. The LIN bus will have a string of data representing zeros and ones. Pin 4 has a positive voltage, pin 1 negative voltage. Now I'm saying this with some degree of caution because vehicle battery systems are positive earth, and this seems reversed round, because we've got a if this was negative and this was positive, there's a diode drop and it would short out. So I expect it to be this way round, with a negative there and positive there. So a fair degree of caution there about that and how it works. I think the short circuit between pin 2 and pin 3, which is equivalent to about 1 ohm, I believe that to be a fault. I don't think it should be there, and I don't know how that's occurred. I think it may be if you're playing around putting pluses and voltage onto these pins and trying them out to try and get it to work, then that has blown this chip between those two pins. With it mounted in this orientation, this is pin 1 to pin 4. I hope that that probably concludes what I've got to say about this thing, except that repair cost for the heating system, which included replacing 3 of these, and the labour, came to just short of £600. Now, I doubt that 3 of these would go at any one time, and I suspect that in replacing these 3, that they've rectified any sort of problems that may have been in the cabling and connectors to these devices. But sadly, that's the way the motor industry works. If you can do the work yourself, and it involves like stripping out the dashboard and things like that, which is quite difficult and time consuming if you've never done it before, you can get these at a sort of fairly respectable price if you hunt around for them.